Okay, let us continue in part 2, okay, of data organization and presentation, still under chapter 2. Alright, so basically, here we want to talk about quantitative data. Okay, remember previously about qualitative data, okay, types of program, gender, right? And here is how we going to show or presenting our quantitative data. Okay. Uh, Similarly, kita akan gunakan frequency or relative frequency table. From that, we are going to try to produce histogram, frequency polygon, two-way table, stem and leaf plot, cumulative frequency table, and ogive. Okay, these are the most common way to display data and highlight the information. Okay, so kita tengok kat sini. Alright, frequency or relative frequency table. Consider the following factors when constructing frequency table. Nak tengok number of clusters, can't be too small or too large. Okay, between 5 to 15, and the class size. Okay, and also the class limit. So class limit ni paling senang kita nak tengok lower and upper limit. And then class boundary is values where each class is joined to the next class. So usually dia akan make middle lah. Okay, ni pun semua kita dah pernah jumpa dahulu, right? And then class mark is the midpoint of that class. Frequency, the number of observation for the class, and we use the symbol of S. Okay, kita gunakan S, right? So we have one example here. The owner of mini market has recorded the number of customers purchasing at his mini market for 50 consecutive days. Okay, number of customers purchasing. So based on this example, he transformed the data into frequency distribution where it split into a few groups, okay, a few classes. Okay, the first class is where the number of customers is between 121 to 140. Okay, so dekat sini dia buat 121 orang ke 140 customer adalah sebanyak 7 hari. Okay, untuk customer, jumlah customer 141 to 160 customers, number of days for that particular number of customers appear and shop to that in that mini market is 9 days. Okay, nampak kat sini. Alright, and then he continue until habislah jumlah customer yang ada kat situ. Kalau kita tengok sini, maximum is 218, I think. Okay, is it 18? Yes. 218 is the maximum. So class 220, the upper limit should be enough lah to cover that number of customers. Okay, so for the relative frequency, kita dah jumpa sebelum ni, kita akan ambil the frequency which is 7, number of days. From the first class, we divide with 40. Okay, sebab dia ada 40 hari. So kita akan dapat relative frequency. Okay, so itu sekiranya diminta untuk menghasilkan relative frequency distribution table, kita kena ingat dia akan start off dengan table frequency distribution yang basic. From that, kalau diminta pula untuk relative frequency distribution, then you just have to take the proportion of each frequency from each class divided by total number of frequencies. Okay. Now let us move on to histogram. Okay, histogram ni paling-paling famous lah untuk presenting continuous data. Okay, quantitative data lah. Right. So it actually consists of series of bar joining each other by class boundaries. So yang mencantumkan dia adalah menggunakan class boundaries, bukan class interval macam tadi kita nampak 121, 140. Bukan. Kita akan menggunakan class boundary iaitu okay, kita tengok kat sini. Let's say the first category is actually 121 to 140, tetapi if we are using the class boundary, then we are going to take half half or 0.5 before the lower limit and 0.5 after the lower limit, right? Or in other words, okay, kalau kita notice dekat sebelum ni, okay, if we notice here, then 140 to 141 is actually the middle. Okay, the middle between that class. So that one become the class boundary. Okay, the number of frequency is remain the same lah. Okay, sama je. Okay, in order to construct the histogram, we use class boundary. Ni kena faham lah. Tak perlu nak hafal pun sebab kita kena cuba faham. Okay, cuba faham dan try buat latihan. Alright, so dekat sini saya tebalkan sedikit. Okay, number of customers. Bila kita dah nak masuk di dalam carta histogram, okay, you can see that we plot here is the boundaries that we found just now for each class. Okay, the first class is 120 to 140, but the boundaries is 121 to 140, but the class boundary is 120.5 and 140.5. So kita plot the height of the bar here, okay, is the frequency for each class. Kita tengok tadi 7 kan? Dan tu je. Okay. From histogram tadi, kita dapat menghasilkan frekuensi polygon. Frekuensi polygon ni is kita menyambungkan, we join the midpoint of each class. Okay. Kalau dekat sini 121 to 140, which is the class boundary is 120.5 and 140.5, kita akan ambil midpoint dia dan kita sambungkan for each bar of the histogram. So kita akan mampu menghasilkan frekuensi polygon kalau kita dah hasilkan histogram in the first place. Right? Okay. Cumulative frequency table. Okay. Cumulative ni dia maksudnya dia akan membawa nilai yang terdahulu into the current summation. Okay. Contohnya kat sini kita dah ada number of customers. Okay. Untuk boundaries pun kita dah study. Okay. Sebelum ni. So kita akan letak less than 120.5 dekat sini. Okay. So for the first class, okay, the boundaries is less than 140.5. Okay, this one the upper limit lah untuk kelas yang pertama ni. Number of frequency dia adalah 7. Right, 7. Dan cumulative. Cumulative ni maksudnya nilai terkumpul. So bila terkumpul, dia belum ada apa-apa lagi nilai pada sebelum kelas tersebut, maka nilainya adalah 7. Okay, when we move on to the second class interval, 141 to 160, 141 to 160, the upper boundary is 160.5. The frequency is 9. The cumulative adalah 7, which is from the previous class, and then tambahkan dengan the current frequency of that class. So 7 plus 9 become 60. Begitulah seterusnya sehingga habis frekuensi distribution yang ditambah dan menghasilkan nilai 40. Cumulative frequency should be similar to the total frequency. Itu cara nak check ni lah kalau kita tambah betul ataupun tidak. Alright. Okay, now OGIF. OGIF ataupun We call it as cumulative frequency curve. Tadi kan kita dah buat cantik-cantik dah. Okay, curve tadi. So, kalau kita dah buat cantik-cantik tadi, macam mana kita nak representing into ogive. Okay, so apa yang kita gunakan adalah untuk menghasilkan ogive ni, we have two types. Okay, less than ogive, increasing function, and it rise to the right, and more than ogive, it falls to the right. Okay, so function ogive ni dihasilkan, okay, graph ogive ni dihasilkan berdasarkan cumulative frequency yang kita dapat tadi. So kalau kita tengok cumulative frequency untuk the first 120.5, okay, kat mana kita dapat 120.5 here, the frequency is 0. Okay, so that's why dia duduk dekat bawah ni. So kita akan crosskan lah 120.5 and 0. And then the next the next boundary is 140.5 where the cumulative frequency is 7, right? So kita akan nampak dia akan naik sehingga 7 with respective 140.5. Okay, kita menggunakan upper boundary less than lah, less than ataupun upper boundary ni. Okay, dan juga 16 is by using 160.5. Okay, so here is 16. So kita just plot macam tu saja dan akan menghasilkan ogive. Dan ini famous lah kalau ditanya di dalam test ataupun dalam final assessment. Okay, kita perlu ada graph paper lah untuk buat latihan ni, right? Then we move on to the stem and leaf plot. Okay, stem and leaf plot ni kita nak tengok distribution. Okay, nak tengok distribution data tersebut. Dan bentuknya adalah, okay, kita boleh nampak selepas ni. Okay, kita terus move ke sini. Stem and leaf plot ni sebenarnya dia adalah number-number bacaan data that we have in our data set. But, okay, dikumpulkan dengan meletakkan leading digit as the stem and the following digit adalah sebagai leaf, right? So, apa maksud leading digit? Let's say we have, where is 45 here? Okay, 45 here. So, 45, the leading digit is 4. Okay, then the blue one will be the stem. Okay, let's say 45, 40 tak ada banyak geng. Okay, 50. Okay. Kita tengok dekat 50, right? So we have 52, we have 58, we have 55, 53. So we need to rearrange. Okay, first thing first, you just rearrange your data set. Okay, from smallest to largest. Okay, ada mention kat sini lah. Okay, kita summarykan, kita akan rearrange into ascending order, smallest to largest, and then for each leading digit kita akan jadikan stem. Tetapi kalau macam 5 ni, 52 ada, 53 ada, adakah kita akan ulang 5 tu berkali-kali? No. We just choose only one and then we rearrange the remaining digit as a leaf. So we do have 52, 53, 54. That's how we can read this stem and leaf plot. And then kita akan nampak the smallest number data set here is 45, the largest is 92. That's how we can read this stem and leaf plot, right? So note here, ditunjuk 4 and 5 here becoming is actually 45. Okay, ini dia selalu bagilah. Okay, we come to the end of part 2. Okay, then kita akan sambung ke part 3. Sikit saja lagi. Alright.